severe. Like, what happened?
Marginal risk of
That's what I'm sure about the SPCA.
Yeah.
That's what I'm sure about the SPCA.
Yeah, I'm just like wondering what conditions and why it was worse than they were predicting.
He's got a body.
Yeah, you know, that actually is a good question.
But wasn't there a large like area with no clouds? Like I saw there was like a.
Yeah, I think so. And I guess.
You typically see that in a severe weather outbreak, though. And I mean, it was a marginal risk. It was kind of like if the instability happens, there's enough dynamics that we could have any kinds of severe weather.
And I guess
but there was also a risk that the instability didn't happen and nothing happened.
But it's weird because it was in the 50s. Like that's rare.
Yeah.
It seems like.
For February, yes.
It was pretty
Yeah.
dry, though. The dew point was in the 30s until that first thing came through, and then it got up in the mid-40s, and you kind of need some moisture to support it as well.
It's just the anomaly in the environment that matters.
Yeah.
Yeah.
For you to talk about the dew point was 51.
Okay, so it did go up. Yeah, it was in like the 30s earlier.
No, I'm actually very
I don't know
curious
if
about
it
how that.
It might.
Has it ever, I mean, has it ever reached 60? I mean, like 60?
In February?
I think so. I think
They're
so.
cold.
But I don't know for sure.
I don't know about
Still
it.
that contrast.
Yeah, so relatively.
I wouldn't be surprised. Milwaukee, we tied our all-time record for the 8th, so we, yeah, so I can't imagine that some other February.
Yeah.
Yeah, you look at Ed's maps with the temperature, and yesterday sticks out like a sore
Yeah.
thumb. It's just like,
I mean, I
We're
know
ready to go.
Pennsylvania has seen 70s in February before. Mid-70s.
yeah.
Well, I know a couple years ago, I think it was like 68 in December. I remember, it was like 68 one day here in December, a couple years ago. And then it got cold by then, but that was wild.
Wow.
Yeah, you're right.
I'm still just super sour about missing out on the 1 week of blizzards and winter weather here. And then literally the night I get here, the warm front came.
Yeah.
That's January too.
Yeah, no, I was just going back. to the
I've
first
never
one.
driven in like,
This should be
below
done.
5-degree
Are you
weather.
walking into your section of the water jug?
And that's when salt is, like salt can be used.
Oh, it doesn't work.
All right, we can get started. Welcome to Weather Watch for February 9th. This is a look at the week-long composite of infrared temperatures. So you're looking at essentially high and low clouds. I'll let this repeat because we've had several big weather events for North America. And it's evident by there's just always something happening in this loop here. So I'll let it run through here and I'll highlight each of these events first. The first one will be when it restarts, watch the southeast United States. Notice.
You can stop it when you get to this.
That's fine. It's fine. Keep going.
Just let it go.
So you'll notice here's a big burst of precipitation. There was severe weather all throughout the southeast into Florida. And watch this cyclone. It'll just keep spinning here, cyclonic circulation. This is now a couple days after it was over the southeast. It's still off the coast of Florida, still hanging out. Then by the time we get to the end of the loop, we'll see this in the visible satellite. It's a very pretty cyclone. Look at it, it's still churning, and it's now, a week later, it's just moved from the southeast to central Atlantic. But a very prolific weather maker for the southeast and then into the Atlantic. At the same time, here's your atmospheric river, if you want to call it that, over Southern California. Dumped about the year's worth of rain to much of the Los Angeles, California area. I saw a report of like 11 inches in 12 hours around the Malibu, Burbank, California region. And you'll see this right here. Here it gets going, and it's just one or 2 days of continuous moisture just being pumped right into Southern California right there. Then on its heels, so this is that initial wave, you'll see another feature come down, brings a little precipitation. There's a tornado in San Diego, which is very rare. That system, I'll let it loop again here. That same system becomes a weather maker for us that we'll see. So here's the beginning of the atmospheric river, just like a fire hose, just dumping moisture. And you'll see, so here's all this mess of moisture and everything. This becomes our major cyclone that brings us severe weather yesterday, at temperatures in the 50s, and then is still hanging out over Ontario and Quebec. While this is all happening, you can notice here's your cold temperatures. You can see the ground temperatures in Quebec, Newfoundland, Labrador, and then into northern Canada. Winter is way up here. Everywhere else is basically in, spring, kind of summertime. And you'll see it doesn't really move. It's all just confined up there. You can see with the daytime heating and the nighttime cooling, it kind of pulses back and forth. There's your cold air well into northern Canada. Now, here we have a system that's bringing a ton of moisture into Nova Scotia. There was reports of like 5 to 6 feet of snow from sea-induced snowfall. And it's all in a period of about 1 to 2 days at the beginning of this loop that I'll point out here.
Do I have to hear this?
Right? Meanwhile, we have no snow over us. Yeah. But they had like,
They're sprouting.
yeah, tulips sprouting. You'll see it right here. Here it just funnels moisture.
Wow.
Then you get ocean-induced snow. And you'll see it's very short-lived compared to this loop. But, 5 to 6 feet of snow. Then, everyone's talking about it. You'll see here's our weather maker for yesterday. There's the first wave of storms. There's your tornado in Wisconsin. There were a couple of them, I believe, as one circulation lifted and dropped a couple times, but first tornado ever in Wisconsin's history in February. First tornado warning ever issued by any station in Wisconsin in February, and they issued about 7 or 8 of them. So all of this has happened in 1 week. It's kind of been a crazy week, but exciting. Luckily, no reports of loss of life with those tornadoes. I hope that continues. And then you'll see at the very end of the loop, we have a really weird subtropical jet-like feature that extends from all the way down in the tropics up into the Carolinas. And you'll see that kind of take shape here as the loop goes forward. So it's kind of connected to...
From the atmospheric river in LA, right? Is that the same?
Yeah, it just
That's
moved.
right, yeah.
It just moved eastward. Yeah.
It's like slowly, ever so slowly moving eastward, but becomes... Can we stop it at the very last image, please?
And this strikes me that if we looked at anomaly maps of like 300 millimile geopotential or 500 as well, there'd probably be a almost persistent trough off the west coast,
Yeah.
and then gradually sinking southward along the coast of Mexico, and that just moves that whole plume further to the east. That's what it looks like in the satellite.
Absolutely.
And that's a March. That's an early March phenomenon
Yeah.
because LA has its coldest month of the year in March at 850, not February. So we're a whole month ahead.
I can believe it. It's 50 degrees yesterday here. And look at how thin this band of assumably clouds is connected all the way to the tropics. And then here's our system that brought us the severe weather. It's kind of muddled and bringing snow into parts of Canada and then also northern Minnesota and Wisconsin. We'll see that in the surface house here. But so it's been a week of weather for sure. Could we please now go to, let's see, the weather.gov page. And then could we click on Madison? And again, we'll have to click on Madison here. And so National Weather Service Milwaukee puts out these archived daily maps that are fun to look at. So if we could scroll down, we'll look at just how anomalous yesterday was, these climate graphs. And then let's do the Wisconsin high temperature. So this is a look at high temperatures for yesterday. Note the date, it's February, okay? We have 60s and 50s, almost 60 degrees in northern Wisconsin. The one thing you'll notice, I've looked at these a couple times, the Madison Ob is always off. We got to 55. I'm not sure what station this is, but it's always about 5-6 degrees colder than what actually happens here. But I mean, look at this. It's 50 degrees everywhere in the state, essentially. No snow cover. You have piles of snow, but that doesn't count. And it's February. So this is just bizarre. And it was, 60s, close to 70 in Iowa, and then 50s and 60s into Minnesota. So this is not just Wisconsin. It's everywhere in the Midwest. And it was February. So now if we could click, I think if we just click on the image, it'll go away. And then February severe weather event. They always put out summaries of severe weather events. So first I'll highlight, they have a text about what happened. Again, no tornado warnings had ever been issued in the state of Wisconsin during February. They issued 5 of them yesterday. And then only a total of 17 severe thunderstorm warnings had ever been issued in Wisconsin in February, and Milwaukee Sullivan issued 8 of them, so about half of what historically had been issued. And you'll see as the day goes on, we'll probably get an update of these tornado tracks. But if we go to storm reports and scroll down a little bit, they have a nice map of all the warnings in the report so far. So we had thunderstorm warnings coming into the southern part of the state. Here's your beginning of your tornado. One reported tornado at this point, but there will probably be several. And even portions of Dane County got into the tornado warning. It surely scared my mom last night. She was texting me like, we're in the tornado warning. I was like, don't worry, it's far away, but still too close for comfort. And some communities did get hit by this tornado and all the severe weather. Evansville, which is, I believe, where this tornado was reported, had school canceled today. Wow. For tornado damage, not snow. I've never seen anything but snow cancel school before, so school cancellation from tornado damage, which is bizarre. You can see how we kind of got the brunt of all the severe weather down here in south central Wisconsin, which is what the risk showed. There was a 2% chance for all the severe weather, and 2% is greater than 0, so we did get severe weather, so that verifies.
I wonder how much that 2% was scaled by forecasters because it was February 8th.
Could be.
It might have been really 20% or something.
Right, that's true. I mean, you see this in February and you think this is not going to happen, no way, and then
Right.
it does. But luckily they had warnings ahead of time. You'll see they had a warning for Monroe and Greene County before the tornado actually touched down. So there was heads up for these storms. You can see the hail tracker also send it in from Iowa all the way towards the Milwaukee region. So very weird day yesterday, but luckily again no loss of life from any of these storms so far.
Did you guys see the lightning too? The lightning was just
It's crazy.
I was afraid I was going to get struck. I was right outside my house, it was right on top of me. It was
Yeah.
really unreal.
And then could we go to the eye candy again, one of the tornado videos or something? And just watch it again. So history, first February tornado in Wisconsin ever. And it hit 30 miles to the southwest. Yeah, it's pretty crazy.
That
Look at that.
picture right there is stunning.
And see, this is in Evansville, so you can imagine why they had school canceled. This is in the middle of the town. Going through.
Oh, boy.
That looks like a nightmare. You never want to see that.
That is literally a nightmare.
Yeah.
Sweet dreams.
That is.
Yeah.
Happy Valentine's Day.
Yeah, right.
Okay. Could we go to our own page, the current visible for North America, please? So if you remember, I pointed out this system, which had been sitting over the southeastern United States, but look at how beautiful it is.
Yeah.
Nice curly queue of clouds. You have a big, long extension getting its moisture from deep in the tropics. You have cold air on the backside producing open cell cumulus. You can tell it's coming off the cold continent. You can kind of make out how this area of Nova Scotia is a little wider than portions of the United States. So this is all the snow that fell from that ocean-induced snowfall event. Here's that big, long extension of moisture from the tropics. You can make it out very clearly. We're kind of in this gross, low-level clouds where we'll see in the surface odds places like Chicago and Milwaukee are enjoying about the same weather as yesterday, and we're in the 30s here because we're in the snow or the cloud cover. And then some of these clouds are actually precipitating snowfall. You can tell they're low clouds because could we stop it at the very beginning, please? This will be useful. You can make out the shadows of here's the higher clouds, but then over us is like a lower uniform cloud deck which moved over and keeping us cloudy for the day. And now we can play it again, please. So there's still a lot going on, and you can make out decent amount of snow cover that fell in Arizona and portions of Utah and then into California as well. From the cloud-free day they're having, but then you can almost make out another system coming on shore based on just the visible cloud cover. So still a lot happening, and here's our system that brought us the severe weather. Kind of getting muddled with all the snow cover and lower clouds, but this is also precipitating now snow into portions of Canada I believe that's all I want to touch on for this one. And then could we go to the surface obs, and that'll be my last spot I show. We'll focus on our region first. So here's Madison, 40 degrees over 30, and we're cloudy, but then Milwaukee's perfectly clear, 47. Chicago's at 54, so maybe approaching another record, just an hour or two away from Madison. You can see where the cloud cover is, it's largely in the 30s, and then where the cloud cover is not, it's close to 50, and portions of Michigan are in the 60s right now. Here's some snowfall to Michigan, and then back into the Dakotas and Minnesota. And then you'll make out, here's some rainfall from the system that moved over our region. It's producing some snowfall into Ontario as well. But largely, aside from the heavy cloud cover us, everywhere to our east, it's a pretty nice day. It's 50 degrees, 60 degrees. It's February again. You don't usually see this ever in February. It's in the 70s to the south. And then even portions of where you'd expect it to be very, very cold. Typically our cold air outbreaks into Montana and the Dakotas are in the 30s and 20s. So relatively speaking, this is a very warm day for much of the country here. And it looks like that trend might continue looking at the forecast for our region. We'll largely stay in the 40s for a couple days here. And that is all I had. Is there anything else anyone wants to see or look at? Yeah.
I just had a question. Do you know if the lack of snowpack in the upper Midwest kind of constructively kind of makes it warmer than it otherwise would be in general?
I would say short answer is yes. You definitely have less albedo, so you can build warmth quicker, I think. You still have a pretty, if we scroll up to Canada, please, you still have very cold air mass that can send shots of cold air to us, and we saw that in mid-January. But I would say lack of snow cover is definitely making it so those shots of cold air are harder to get, way south because they get mixed out quicker and warm quicker than they normally should for this time of year, especially.
I think it makes it a lot easier for the sun to heat things up too, both the
Yeah.
albedo, like you were saying, but also you're not melting, with the energy to melt the snow.
Yeah, exactly. It's wasted.
Yeah.
It's all absorption.
Exactly. So this is probably very anomalously warm, even though it's below freezing. But I believe the portions of this portion of Canada, the prairie provinces, haven't had a lot of snow either. So even this snow cover in relatively cold temperatures is not doing much. It's probably getting heated out and melted once the sun comes up, and once these cold shots go away. Anything else?
All right, thanks, Patrick. Pete, can we go to your Super Pete's? Some of the things that Patrick was showing on the satellite are really of great interest. And one in particular, I'm going to focus my discussion on what happens from the northwest part of North America now until Tuesday and Wednesday over the northeast United States. So there'll be an evolution that's kind of going to involve some features that we can see right now. They couldn't be seen on the satellite because these are now stealthy features right now.
This is yesterday's map, sorry. There were some, we'll do the damn one.
Oh yeah, that's fine. I don't care if it comes from the name. Because it's going to be this baroclinic feature right here that's of interest to me. So we'll take a look at this. Notice that it's downstream of this kind of micro ridge, and so I'll say something about that when we go to Viz 5B. But that's very hard to detect. There's no obvious weather feature associated with this thing as presented on the satellite picture. All of that stuff was more obvious from the tropical plume. We'll see some evidence of that at these upper level charts as well. And then here's the big cyclone that we saw spinning around off the Atlantic coast. So this kind of a baroclinic zone looks somewhat innocuous, even though it's a fairly large gradient. Here at Nanaimo on Vancouver Island, it's minus 18, and you get into the minus 30s. So about 15 degrees or so across this baroclinic zone, even though 10 is shown in these three isotherms. And then the other thing that's quite interesting about it is along much of that gradient, the thermal advection, at least by the geostrophic wind, is almost zero. But there is cyclonic shear here. There's also a little bit of confluence of the flow, at least in the northern part of British Columbia. So I think what we'll see with Viz 5D, I'm looking at an initialization from 06Z, I think. So it'll be a little bit back behind this. But I want to trace the evolution of the vortex structure in this feature. Right now, it's mostly shear vorticity. It descends southeastward, south-southeastward, over the Four Corner states, gets a little bit more circular, isotropic, and all the while, this subtropical jet of extraordinary strength, which we'll visit in just a minute, and we saw on the satellite, is going to be providing some sort of barotropic shear in the background all the way through as this feature spins up and then traverses across the country and spells a little bit of winter for southern New England by the time the end of the day on Tuesday. So that's what I want to show you. But let's look at a couple of features here. This is the one in 500. That's enough to show right now. We'll revisit it in Viz 5D. You can also see strong flow, 70-knot winds plus just about everywhere along the southeast coast. One doesn't notice much of a gradient. There's a little bit of a gradient. Actually, it's anticyclonic shear over the southeast states slightly at this level. Let's look at 300 millibars though. So here's the core of a jet at about 155 knots, sitting right across the southern states. I'm not sure that's going to be the strength of it, the greatest strength of it. We'll go to higher elevation in just a minute. But right along the baroclinic zone position at 500 millibars, you see a really strong and narrow linear feature. This jet is about 124 knots, digging straight southward. And so one imagines it's got a fairly stubby jet exit region. There's going to be upper divergence in this location, ascent, cooling the air in the places where the air is already cold. So it gets colder and colder and colder. It's thermally indirect circulation at the jet exit region. And that tends to dig the upper trough. The heights will fall here because the thicknesses will go down. And so the heights will fall. That's where we start to carve out the trough that will have an impact on Tuesday. It's actually not the leading one that gives the most impact, but we'll see that as we look at the evolution. Can we go to 200 millibars? Might as well go to 200 right away. See what that looks like. Even more intense. Yes, that says 208. So there's a wind at Nashville that is reported to be 200 plus knots right now at 200 millibars. So that's FedEx hub, right? So if they're going from Nashville to Hamilton, Bermuda, they're going to get there really quick today. So you know, that's what you want to be doing, sending something through FedEx to Hamilton. Extraordinary wind speed, just extraordinary. And one can see that it goes all the way, the projection gets kind of funky, but it goes all the way into the subtropical Pacific and then straight across the Carolinas. This contour here is 190 plus, and that goes all the way from west of Oklahoma City to Beaufort, North Carolina at 200 millibars. So Charlotte is a hub for US Air or maybe some other airlines. They have to know about this, of course. So does Atlanta, which is Delta's hub. Nobody wants to fly across this jet, so they're probably staying at low elevation underneath it and then getting high if they're going up to Seattle or up to Western Canada. So really, really interesting, extraordinary feature. So it's no coincidence, although the connection is vague, that we have the first tornado ever in Wisconsin in February, and we have this kind of a subtropical jet. They're not completely unconnected to each other, the unprecedented nature of them. So this feature here will remain for much of the rest of the the weekend and the early part of next week. And as I say, I think it will provide a background that nurtures the development of a still nascent upper level feature that will eventually spell, you know, a pretty little bout of winter for, you know, around Valentine's Day for New England and the Middle Atlantic states. So that's what I want to show you in the forecast. Before we go to Viz 5D though, Pete, can we go to our own maps? And you're going to laugh, but I want to look at the GFS forecast on the 104 grid, or 212 grid actually. I don't want the 104 grid. So back to our normal page, if you can find it. Yeah. So right here. Maybe the 12 is in now. I don't know.
This is on the 211 grid.
Yeah, that's what I want.
Okay.
So let's see what the initialization says. This is 500 millibars this morning, 12Z. So at the southern end of this strip, where we had a northerly jet streak, and then this is the sort of entrance region of the subtropical jet, there's a pretty decent vortex over Southern California. Patrick drew our attention to that from the satellite perspective as well. We saw some open cellular convection underneath the cold dome here, and then also some swirl over inland, the Inland Empire in southern Nevada. And then here's this big ridge over the eastern 2/3 of the country, underneath which the temperatures are spring-like, extraordinary. And we are on the slightly past the backside of it. So it doesn't look like there's much of anything going on there, right? Let's go 12 hours in advance of that. Not at the surface, at 500 degrees. So here's a 12-hour forecast. It looks even worse. I mean, this feature here is kind of the one that was over Southern California, is now over Arizona. maybe this sort of a string of pearls of little vortices here, but what's going to happen to them, it's hard to tell. You wouldn't really say this is going to be a really spectacular weather event. Let's go 12 more hours, and after that we'll go to this back. Starts to look a little more interesting all of a sudden. That this thing gets much more coherent, and that's a very sharp upper vortex feature. It's mostly shear vorticity, of course, and in a minute we'll do a cross-section through that and see what that looks like in this 5D. So that is the beginning of the feature that is going to spin itself from a linear feature under the aid of this persistent subtropical jet, and from a linear feature to a more isotropic feature, and then ride across the country and really have some impact downstream. So it's pretty interesting evolution that I think we can talk about. So thanks, Pete. If we can go to Viz 5D now, I've got a whole bunch of things saved that I'll probably partly remember and probably won't. So here, as I said, I'm looking at the 060 initialization. So this is the first panel. I think they go every 6 hours from here on out. And this is the baroclinic feature. This is 500 millibars approximately, 5.4 kilometers. And then these blue lines are pressure values, because it's from the, Viz 5D puts it into height coordinates. So these are isobars every 3 millibars. And then these are isotherms, or isentropes, every 3 degrees Kelvin. So there's the strong baroclinic zone along the British Columbia coast. And notice that part of it, the flow is coming straight at the warm side and then parallel to the cold side. So there's a little bit of frontogenesis here. I'm not going to show you that, but you could probably intuit that right in this region. But there's also geostrophic warm advection. And so they seem to perhaps be incompatible for the development of an upper front. And maybe that's right. But if we look at omega, or W, I'm showing just descent, so this is ugly, and I don't have any control over smoothing it. One of the fallbacks, the negative things about this 5D. Luckily, up in here, though, I have a subsidence region in exactly where I might expect it. Here's the baroclinic zone. It's weakly frontogenetic. This is subsidence on the cold side. Okay, that's interesting, right? What if I put a cross-section through there? So I think that might be the first one that has theta. Let's see if I'm right. Yeah, it goes right through it. And then there'll be other variables we want to look at. Let's look at theta first, though. And just tilt it up. Remember, it's going right through that baroclinic zone. And it's a pretty decent upper front. Look at that. It comes almost all the way down to the ground. This is probably the mountains. So that's a pretty decent upper front. Big ridge just upstream of it. Let's put W on top of that. Oh yeah, that's all subsidence, right through the jet core pretty much, and on the warm side. So this, even though this is frontogenetically driven, it's kind of a little bit toward the warm side in this cross-section, just as Kaiser and Shapiro and others have said for years. And that's one of 3 things that can work in concert to develop the upper front. But this one here, I think, is working on its own right now, because there isn't any cold advection in cyclonic shear, which can induce the other 2. So this is all the frontogenetic upper frontal tilting. And what about PV? I think I put that on this thing too. Yeah, so you can see just a little bit of a tendril coming down in the region of the subsidence. You put the theta back on, Pete. You can imagine this is the highway. All these tilted isentropes are highways by which downward advection along that slope is going to drag the PV further and further and further into the troposphere. So this is setting the stage, and let's remind ourselves where we are horizontally by going back to the top. Right in this location, in this baroclinic zone, just past the ridge crest, is a spot where, hey, something's getting going here. And I should have told you this, Pete. Let's go back. I think I put vorticity on here as well. But maybe that's in the next cross-section. So let's just try QZ. Yeah, it's on the other one. Okay, so it's not on this one. Okay. So, but that's the beginnings of a region of development of, some sort of mid-tropospheric vortex structure that might have some impact downstream. And it's, I think, driven by horizontal frontogenesis, and in a way that's not at all confounding. It's positive frontogenesis, so the subsidence region is what's driving the subsidence of the PV. That's textbook, except that's not how it usually works with upper fronts. But it's textbook ingredients. So very interesting. Let's go back to the top, Pete, if we could. And we got to get rid of a whole bunch of this stuff now. W's got to go. Maybe the pressure's got to go. We'll just keep our eye on theta. And if we put PV on here, and I colored it in too, just to give you an idea what the structure looks like to begin with. So here's the, this is 1 unit PV at 11.5 kilometers, way up there. I'm at the subtropical jet level. 1, 2, 3, 4 PV, and then shaded in as well. So right in that region where we had our cross section, you can see there's already a decent background gradient of PV. That's reflected in the jet that we saw at 300 millibars, and at 200 as well, the narrow little jet. So it's all consistent. And that's really the only piece that may have a chance to develop. And if you start forcing this high PV downward, you're going to start to develop a little bit of lower tropospheric trophiness as well. Look at this beautiful treble clef looking structure associated with that storm. What do you think of that, Coach? That's perfect, isn't it? Just perfect. Okay, let's march ahead a few times here. We're good. This is at 6-hour increments. And you can see not much appears to change along this. I think we had to go to 18 hours. What time was this one, Pete?
I think it was 24 hours.
Valid at 12Z. So we're going to be, probably can get this at 6Z, so it'll be a 24-hour forecast of this thing. Let's go to about 24, maybe one more. We'll start to see something like that, I think. Click ahead one more time here. I guess it'd have to be one more, so let's say right there. So we're starting to see a little bit of a separation of this particular feature over Nevada and parts of Oregon and Idaho. And I don't know if I have my cross sections here yet. Let's try. Let's put, no, I already have them saved. I just don't know where they are. It's further down, so we got to keep going in time. One more, one, right there. That's it. So this is 12Z Saturday, same as that, I guess. It is
Exactly,
same.
yeah.
12Z Saturday. So we're looking now at this feature in this cross section. So let's tilt this up. You can see how it's becoming just a little bit isolated in the PV and very low latitude. So it's a little droplet of PV. Wow, look at that. So there's the upper front tied to this thing, and it's definitely an upper front. You just all of a sudden isotropes go flat at 700 millibars, and that's where your gradient is. So let's take a look at PV on there. So PZ prime. A little bit more penetration of the high PV down to this level here is 5.4 kilometers. So we're at about 450 millibars, maybe, where we have the PV down to already. Let's put W on there. Not that one, I guess it's probably this one here. And there's your subsidence in this cross-section. So that's continuing the upper frontogenesis process. It's not strongly dragging the PV down in this particular cross-section, but the whole thing is working in concert. And let's go back to the top and take the PV off for the time being. And then put the pressure back on. I always like to put the pressure on. And you know what, that was a joke. All right, not much geostrophic temperature section. Really, look at this. Look at the parallelism of the isobars and the isotropes. There's very little temperature advections. This is not being driven by that characteristic mechanism. This is driven by something else. I think in this case it's confluent frontogenesis again. The substance is right there. It's right where it's doing the most damage. And just if we take everything off for the time being, we'll leave the cross-section lines on. We can at least see how strong that, I'm sorry, I meant everything except theta. Look at how strong that temperature gradient has gotten over Southern California. These are every 3 degrees Kelvin. So that's extraordinary. It's 15 degrees over, the width of the southern part of the state of California. So this thing's really starting to rev up. If we put the PV back on there, please. And then, yeah, right. So there's your upper teardrop, upper trough. I think I have ice attacks. Let's go for speed. Oh, not in the cross-section, sorry. And here's the subtropical jet. Here's the core of it right there. And it dips a little bit further south over into the southern part of the Baja Peninsula. So this whole region polar to this is subjected to a cyclonic shear by the presence of the subtropical jet. So this thing already, seemingly on its own, beginning to kind of peel off as a cyclonic vortex, is going to have that tendency enhanced by sliding off to the north and east. So let's take the speed off. And we can take the theta off too for the time being. And let's just, and take the cross sections off too if you don't mind. And then let's just walk through this and watch what happens to this structure as we go forward. So there it is, kind of still sagging southward, but look at how isotropic it's going to get. And very much divorced from the umbilical cord to the high latitudes. Now it's pretty much its own entity. And right there, let's stop and put sea level pressure on. And this is everything 1,012 millibars or lower. So there's kind of a broad region of very slightly reduced pressure over the western Gulf of Mexico. Let's watch what happens when this thing gets close to that feature. And you can guess this bulge right here turns into its own little cyclone. And there it goes. to town. This feature is now completely cut off from the high latitude reservoir. It's still subject to the cyclonic shear by the presence of the jet to the south, and now we're starting to see a development here, 1004, keep on going. And look at how that relationship is maintained, and the deepening continues for this thing. So this is why, now we're getting to about Tuesday, right, midday? Right, at one more time? Right about here, 992 off the coast, tied to that feature that developed first in the northwesterly flow, then began its own isotropic transformation that was intensified by rolling along on the cyclonic shear side of the jet. Let's take the PV off now, and let's put theta E on there. And I think this is at just shy of 2 kilometers, is that right?
1.6.
1.6, so about 850. Look at this beautiful thermal ridge right in there. Absolutely gorgeous for this storm. Let's take, I got a cross-section here of theta E, probably that one.
That's just there.
Rats, I thought I had, oh, maybe it's the only one I have. Yeah, that's it, it's theta E right there. Let's look at that from the east. So there's something that looks like a trowel structure. Here's the warm frontal portion of the theta E of the trowel structure. Here's the cold frontal portion. We've got it at a kind of a weird angle, and for some, that probably is the reason why it looks a little bit funny. But no doubt the 318 Kelvin theta E line has the trowel structure. 315 goes all the way to the ground on both sides. And so that's where one might expect you're going to have the pretty heavy vertical motion and precipitation. Let's just check that. Oh yeah, that's where it is. Really nice. And if we go back to the top view, vertical motion like crazy, that's right in this region. So it's snowing like crazy in this portion of the storm, including my hometown. And so there's, 6 to 8 inches of snow maybe on Tuesday for them. Let's take a look at the surface of theta E. And we can see the low pressure on top, get rid of the cross sections, I guess. And you can see there's the notch in the PV. So this is colored by pressure. So these are low pressures and these are higher ones. And so the air is coming up through the circulation of the cyclone and going right like that. Bring the map to the top so we can get a perspective of where we are. Thanks. Yeah, so that's all occurring over southern New England, right in that region. And I had some trajectories, but I didn't have enough time to really get the ones that I wanted to best illustrate that. But you just can't miss the structure as it evolves. So this whole, yeah, that's a great idea, Pete. I was just going to say it. Pete and I think almost the same. As you've probably noticed over these weeks or months, I was just thinking exactly the same thing. And this is at fairly high resolution, so you get all these kind of this pixelated edges to this and whatnot. In the old style, when you had a 90-kilometer model to look at, they were a little smoother, but you can still see the structure in that. Isn't that gorgeous? One imagines warm sector air comes right up the funnel there of higher than 312 theta E, and then goes right up the chute, and that chute is over southern New England, and that's why it's going to snow there. And this is now the third day in a row that's been the forecast, and the storm looks roughly the same. And I'll point out one last thing. 992, this is, it's a decent storm. I'm a beggar, so I'm not going to be the choosing. I want to see anything. But this is not the kind of storm you write home about. However, if you're commuting, what time? It's like midday on Tuesday. If you're thinking about how are kids getting home from school at 2 o'clock in the Boston area or the Providence area, you want to know about this. You want to know about a 992 cyclone that's going to give you maybe 6 to 8 inches of snow in mid-February. You do want to know that. And I think we're at a point in our science where you can say, this is going to come from the Queen Charlotte Islands, formerly named. They have a native name now, which I don't remember. But the Queen Charlotte Islands off the coast of British Columbia. That's where this thing came from. And you can talk about that in an intelligent way, and that's really exciting to me. So that's what I have. For us, I forget what the weather's going to be. It's just going to be a continuation of boring, I think. But I didn't look at it. I just didn't look at it. I was more interested in this. So if anybody would like to talk about our own weather, that's fine. I could certainly
It's
indulge.
going to cool down a bit over the weekend and then warm up a bit.
Okay.
Next week.
Oh, and we're still fourth warmest through February 7th for the Northern Hemisphere cold pool. And we are within striking distance of the all-time record. We're not so far away. It's not like in the old days where McEnroe and Borg were number 1 and 2 and then didn't even know who number 3 was. It's not like that. We're close. There's a bunch up there. And so I am really hoping against hope that we keep this up. I'd love to see that broken. We get this close.
I should show Ed's map too real quick.
Oh, is it about the precip?
Well, just the climate ones.
And I'll say while you're getting that, Pete, one thing about the precipitation, it's gonna show up in our Monday column, Steve, in my Monday column. Wow, look at that. That's your proverbial sore thumb. So that's the average temperature on, can we go a little further down so we can see the date? That's the average temperature on April 1st.
Yeah.
So we're 2 months ahead.
This was our winter, it was like 2 weeks.
Yeah. Take that out, and as you saw last week, this was coincident with a hemispheric decrease in the cold pool, not an increase, even though that was continent-wide. So, and then we're back below normal for precip, and about by 0.3 inches. And then somebody brought up about snow cover. We'll get out of here in 1 minute. The lack of snow cover. It's bad news for the farmers. If it stays warm and we don't get snow, water is leaving the ground every single day from here until March 30th when they want to turn it over. So it's very bad news. It's not irrevocable. They can't, undo it. They can, but it's costly, and nobody wants that. So it's not a small thing. Okay, thank you, Pete, for your driving. Anytime you bring Biz 5D in, you really get to show off because you're so good at it. Appreciate that. Patrick, again, excellent discussion to lead us off. And everybody, thank you for your attention. We'll see you next week.
Thank you, Jeff.